Hello students and welcome to Unit 6 Part 2 Lesson 2. In this lesson we are going to continue learning about scatter plots and add to our knowledge information about lines of regression and the skill of making predictions. Our previous essential questions, which we will review at the beginning of this lesson, are: what are scatter plots? What do they display? How are they constructed? And what do correlations tell us about a relationship? To this information, we are going to add what a line of regression is, how we can use that line of regression to make predictions, and how we can write an equation that can also be used to make predictions. So let's begin by reviewing Lesson 1. In Lesson 1, we learned that a scatter plot is a graph used to show bivariate data. And by bivariate data, we mean bi meaning two, variate meaning variables. Two variable data. This two variable data must be numeric, meaning it has to be of number origin. So for example, bivariate data could include a person's height and weight because these two variables are measured using numbers. Time spent studying and the score on a quiz is another example of bivariate data. Two variables that are linked together and recorded as numeric results, numbers. In Lesson 1, we also learned to create a scatter plot, and we all learned that once it is created, it shows us a correlation. A correlation tells us how closely the two variables are related and the direction of the relationship. Do they increase and decrease together? Does one increase when the other decreases, or is there no relationship between the two variables? It also tells us how closely they're related by describing it as a strong relationship or a weak relationship. There are three types of correlation that we've learned about. The first one that we learned about is no correlation. That is when there is no significant relationship between the variables. We see them on a scatter plot as dots randomly dispersed throughout the graph. There seems to be no rhyme or reason, no pattern to the dots at all. The second type of correlation we learned about is called a positive correlation. As one variable increases, so does the other, and this can be strong or weak. This is an example of a strong correlation. It's very linear. The dots are very close together, and they're increasing together because the dots seem like they're going upward. Also can be remembered as positive slope goes upward from left to right, as does a positive correlation. And last, negative correlation. A negative correlation implies that as one goes up, the other goes down, and it creates this downward pattern of dots that can be either strong or weak. Now, knowing strong or weak is one thing. It links the two variables together, but statisticians and quality control technicians want to create a way to make predictions. So if this data is true, what else is true, and what can we imply from this information? A line of regression is used to make predictions, and the rest of this lesson is going to focus on what is a line of regression and how do we use it to make predictions. So let's begin by defining a line of regression. A line of regression is a linear function drawn on a scatter plot that best represents all the data. So in other words, if you have a scatter plot and you have all these dots, if you draw a line down the center of the dots, it kind of represents the direction that the relationship goes in general. The line should match the direction of the correlation, meaning if you see a positive correlation, then the linear function should have a positive slope. If you see a negative correlation, you should see a negative slope on your line. That's what it means by match the direction. And approximately half the dot should be above and half the dot should be below the line of regression. And both of these characteristics must be true. Once drawn, the line itself and the equation of the line can be used to make predictions, and we'll focus a little bit more on that a little later in the lesson. So let's first talk about drawing a line of regression. So here we have this scatter plot that represents the time since cookies have been baked and the number of cookies left in the jar. We saw this same scatter plot in the first lesson, and we said that it had a negative correlation. Well, when we draw a line down the center of these dots, kind of like this, we can see that negative slope because we see that it's going downward. See how the line's going downward? Just like these dots had a negative correlation. Now, this line matches that downward trend of the relationship, and we also see that 2 of the dots are above the line and 2 of them are below the line. So it matches 50% above and 50% below, just as it needs to. So this is a line of regression that represents the general trend of this relationship. Let's now draw a line of regression to represent this relationship, which is between the number of beach visitors in comparison with the average daily temperature. We can see that these dots have a positive correlation. They're going upward in general, which makes sense because the higher the temperature, the more people that want to go to the beach. The opposite's also true. The lower the temperature, the less people that go to the beach. So to draw a line of regression, we would want to draw a line through the middle of the dots, matching that upward trend. Do you see how the dots are going upward? The line is going upward. And also trying to get half of the dots above, half the dots below. So we have 1, 2, 3, 4, 5, 6 dots above and 1, 2, 3, 4, 5 dots below, which is pretty close. We also want to make sure that none of the dots are too far away from the line, unless they're an outlier. It's okay to ignore 1 or 2 of the dots, but not a lot. So you can see that this distance here away is pretty similar to this distance here away. So we can say this is pretty typical for the visitors and temperatures. So here's a sample multiple choice question. It reads, which of the scatter plots below shows the most accurate line of best fit? Well, when I look at the dots, I see that they're going upward. And I see that all the lines are going upward. So that's a good start for a line of regression. Only one of these, though, matches the tendency of the dots. Do you see how in this line, all of the dots are below the line? That doesn't match the 50-50 criteria for a line of regression. Here, we see some of the dots are actually on the line. There's a few below and a few above. This does match the upward trend, the positive correlation, and the 50-50. Here, it has the upward trend, but most of the dots are above the line, and there really isn't any dots below the line. So the best scatter plot with the best line of best fit, which is also known as a line of regression, line of best fit and line of regression are synonyms for each other, is this center graph because it matches the positive correlation. Half the dots are above, half the dots are below. Now, extending upon a line of regression. The purpose of a line of regression is for a linear function to be used to make predictions about a nonlinear relationship. The dots on a scatter plot typically do not lie on a perfectly straight and predictable path. Therefore, the line of regression generalizes the relationship in order to make predictions. In other words, when we look at a graph such as this one, the dots do not lie on a perfectly straight line. So an equation cannot be written for these random dots, but when we generalize it with a line of regression, we can start to make predictions. There are 2 ways to use a line of regression to make predictions. The first is that the line of regression can be used or extended to make a prediction about a situation represented on the coordinate plane. And the second is that an equation can be written for the line of regression to make any prediction or to explain the relationship further. The difference between these two strategies is the first one is a visual strategy. You must be able to see the prediction that you're looking for on the coordinate plane. The equation option is an algebraic situation, and you can make predictions about any situation. Now we're going to focus on the first one to start. So here is the same coordinate plane with a scatter plot and the line of regression that we drew earlier. We can start to make predictions based on this line as long as it's on this graph. So for example, this says about how many cookies were in the cookie jar on the first day. So the first day would be when we started. That's at 0. So if we extend this line just a little bit further, it would be about right here, right above this line. Well, if we look at how this counts, this would be 18, this is 24, so this goes up by 6. So each of the lines goes up by 3, meaning this line would be 3 more than 24, so this is 27. And this dot is right above that, so we can predict maybe there was about 28 cookies on the first day. Now we don't know for sure, but this is just an approximation because it says about. Let's make another prediction based on this graph. About how many days will it take for there to be no cookies left in the cookie jar? Well, no cookies would be down here at 0. Well, where does this line have y equal to 0? Well, right here. Okay, well, what day would that be? Every other line counts by 1. So this is 1, 2, 3, 4, 5. So on the 5th day, we can expect there's probably going to be no cookies left if this pattern continues. Let's look at another example. In this scatter plot, the number of hats that are sold is being related to the number of games won, because we know when a team starts winning, fans jump on board, sell more merchandise. So here's our 2 prediction questions. About, meaning we can make a prediction, about how many hats were sold before the team won any games. So when they won no games, how many hats were sold? Okay, so go up to here. So this graph is counting by 100 on every other line. So in other words, it's counting by 50. So 50, 100, this line would be 150. And this is just maybe a little less than that. So maybe about 140 hats were sold before any games were won. Now, if one person said 140 and one person said 135, they would both be correct because it says about how many hats were sold. Now, let's continue to make a second prediction. About how many hats will be sold if the team wins a 9th game. Now, our graph only counts up to 8, but we understand that this line's 9, so let's go up and find where that is, which would be this point here, and go over to our y-axis, which would be about right here, and figure out what that value would be. So this would be 100, 150, 200, 250, 300, 350, 400. This is 450. This line's 500. And this is just a little less than halfway between there. Halfway between there would be 475. So we'll say about 470 hats are predicted to be sold if they win a 9th game. This helps teams to know how to stock for what they might sell.